Here we go with finding the surface area of a surface of revolution. We're going to take the function y equals square root of 4 minus x squared on the interval from x equals 0 to x equals 2, revolve it around the x-axis. By now, you should have seen this monster, which is the formula generated through a partitioning analysis. This is how we compute surface area of a surface of revolution when it's a function of x revolved around the x-axis. And so the flow of these problems are all very much the same, so I've already prepared little bits that we can fill in. For the derivative of our function, this is 4 minus x squared to the 1/2 power, so the derivative will involve 4 minus x squared to the negative 1/2 power, which puts it down there, and then we'll multiply by the derivative of, there's the 1/2 from the original exponent, and we'll multiply it by the derivative of 4 minus x squared, which is negative 2x, and those negative 2's are going to cancel. And so if we square that, then we're just going to have x squared on the top and 4 minus x squared on the bottom. And then when we add 1 to this, remember 1 can be written as 4 minus x squared over 4 minus x squared. So we'll have a common denominator of 4 minus x squared, and 4 minus x squared from the 1 plus the x squared from here leaves behind a lone little 4, and then the square root of that is just going to be 2 over the square root of 4 minus x squared. And now we're ready to load up the horrible surface area equation. So we're going to integrate from 0 to 2. We'll have 2 pi times the original function, and then we're going to multiply by this tail end that we just created, and oh, look at that, something nice is going to happen. These terms are going to cancel. It's almost like you can plan problems out so that they become relatively simple. And this will be the integral from 0 to 2, 4 pi dx, which is 4 pi x from 0 to 2, and that's just 8 pi. Which is, golly, that's a nice number for something that seems as weird a function as this. But if you hadn't noticed it already, we're just working with half of a circle. Square root of 4 minus x squared is the, well, it's a quarter of a circle. It's the upper half, the right half of the upper half of the whole circle. And so here's a picture of what just happened. We took square root of 4 minus x squared from x equals 0 to x equals 2. We spun it around the x-axis, and what that does is it generates, this is a bad picture, but it's supposed to be the hemisphere that was created by this revolution. And we know the formula for the surface area of an entire sphere, so we could just calculate that entire surface area of that sphere of radius 2, and then chop it in half, and what would we get? Well, we'd end up getting 8 pi. And so that's why that number happens to be so nice. Now, in the other example I will post, we will see an integral that is anything but nice, and we'll take a look at what we can do with it.